This is a very quick video to introduce the names of three very important kinds of triangle. And the reason that I've drawn them already is because I wanted to try to make them look reasonably correct rather than drawing them very quickly and making a mistake. So if we look at this, we can see, first of all, on the left-hand side, we can see, that's not very good, you can't see that at all, can you? We can see that I've drawn this equilateral triangle. And what matters about an equilateral triangle is that it's regular. It has the same sides all the way around, three all the same, three angles the same. And if you turn the triangle round, it looks the same if you rotate it through 120 degrees around each way. And equilateral triangles are quite common. And for example, if you look at the hexagon that we had in the first video, if you draw a hexagon like this, a regular one, then the hexagon, if you draw the diagonals in, all of these triangles inside are equilateral triangles like this one. So if you take 6 of them and stick them together with all the points in one place at the middle, there you get a regular hexagon. And an equilateral triangle is a very pretty shape, and you can do all sorts of things with it. So it's got 3 equal sides and 3 angles that are all the same, all 60 degrees. If we come up here, you can see that I've drawn an isosceles triangle, as it's called. And an isosceles triangle has 2 sides. This side and this side are the same length. And that means, because if you draw a line down the middle, I'm going to make it a little bit thicker than that so that you can see it. If you draw a line down the middle here, then the triangle's exactly the same on both sides. In other words, if that was a mirror, it would be a reflection of itself. And that means that these 2 angles here, well, it's too thick now, isn't it? This is A, this is A. They're both the same. And we're going to come across isosceles triangles a lot in the next video, so it's important that you remember what they are. It's a funny word, it's another Greek word, and it basically means, the word iso just means the same, and skeles, or celes as we say, means scale. So it means same scale or same length, 2 sides the same length. Of course, if you have all 3 sides the same length, if this side at the bottom here is also the same length, then it becomes an equilateral triangle. But usually that's not what happens. And then probably the most important of all is the one that we've got down at the bottom. And this is the right-angled triangle. And we'll see why they are so important later. But basically, it's any triangle that has one angle, this angle in here, of 90 degrees. Why is this so important? Well, for a very simple reason, which is to do with the fact that we can make a triangle of this kind with the 90 degrees, and we can make it of any size we like. So for example, we could make the bottom line 100 miles, or we could make the vertical line 1,000 feet. And if we keep the proportions of the triangle, the relationship between the sides, the angles, are the same. It's what we call a similar triangle. We can use triangles like this to do calculations of all sorts that turn out to be absolutely fundamental to the way that we understand the world. So right-angled triangles are far and away the most important of these three, and we will have a whole video just on them in the future. I just want to say one more thing about circles. If we draw a circle like this, ooh, that's a good one, and we find the center here, and if we draw a line from the center to the circumference, it helps if it's long enough to reach the center, of course. Here we go. And then we draw another line from the center to the circumference. These are both radiuses, or the proper word. Each of them is a radius. You'll remember that perhaps from the very first video, and when you have more than one, the plural is radii, two i's. It's a Latin word, radii. If we take those two radii, which are both the same length, we mark same length like that, then if we draw the chord, let's put some letters. The center is O, that's A and that's B. If we draw the chord AB, you'll remember it's the line joining 2 points on a circumference, then this triangle and all triangles that you make using two radii like this is isosceles. You can probably see that it's isosceles because it looks pretty much like the one we drew on the previous picture. And that means that this angle here, let's call it A, and this angle here, call it A, those are both the same. And this is still true for any triangle. So, for example, if I draw a triangle, we'll have a red one this time, with very narrow angle at the center, these two red lines are still radii of the circle. They're the same length as the ones in the first triangle. And if we join that line there, then we get another isosceles triangle, so that angle is the same as that angle. And even if we draw a really, really wide angle at the center, let's do it in blue and have one over here. So the angle at O, this angle in here is really, really big, and we join the chord. Missed, never mind. Then these angles in here are again the same, and it's an isosceles triangle. But of course, the three-line blue angles and the two-line red angles and the one-line black angles are not all equal to one another, because in these triangles we've changed the angle at the center. So the blue triple arc angles at X and Y are equal to one another. The red ones here, I didn't put a letter on, let's call it P and Q. It's always important to mind your P's and Q's. Those two are equal to one another, and the two angles at A and B
they are equal to one another. So that's always true in a triangle, that if you create, in a circle rather, if you create a triangle using the radii, the triangles you create with the chord are always isosceles.